Welcome to this explainer. Let's jump right in, because today we're taking a deep dive into one of the absolute best tools in a software architect's toolkit for taming complex systems. If you've ever stared down a massive, tangled code base and just wondered how on earth to make it manageable, well, you're in the right place. We are going to demystify the facade design pattern.
But before we even touch a line of code, I want you to picture a really high-stress scenario. You're organizing your dream wedding. Think about everything involved: the venue, the catering, the photographer, the DJ, the flowers, wrangling the guest list. It's totally overwhelming, right? So here's the question. Are you going to personally call every single vendor yourself and try to manage all those chaotic schedules and contracts? No way! You'd hire a wedding planner. With a planner, you interact with exactly one simple interface, them, and they handle the chaotic web of services behind the scenes. In software design, that wedding planner is your facade.
So here is our roadmap for this explainer. We'll start with shifting to structural patterns, hit some everyday facade analogies, and then defining the facade pattern. After that, tech examples in action, a peek at the code, and finally, pros, cons, and comparisons.
Number 1. Shifting to structural patterns. Okay, so in software engineering, we have different categories of design patterns. You're probably pretty familiar with creational patterns already. Things like the singleton or the factory method. Those are entirely focused on object creation, literally how we bring objects into existence. But today, we're shifting gears. We're crossing the bridge from creational patterns over to structural patterns. These focus on organizing and simplifying the structures we already have. We aren't just creating things anymore. We're figuring out how classes and objects are actually stitched together to form larger, more flexible, and easier to maintain systems.
Number 2. Everyday facade analogies.
To really visualize this, think about the last time you went out to eat. In a restaurant, there is a massive team working together to serve you. You've got the kitchen staff, the head chef, the cashier, the dessert station, maybe delivery drivers running around. But as a customer, you never talk directly to any of those people. You talk to your waiter. The waiter is your facade. You just place your order and they handle literally everything else. They coordinate with the chef, they check the tab with the cashier, and they bring you your food. You just get to sit back and enjoy the meal without needing to know a single thing about the chaos behind those kitchen doors.
Number 3. Defining the facade pattern. So mapping that to code, formally speaking, a facade pattern provides one simple interface that hides the complexity of multiple subsystem classes. The client doesn't need to know how the underlying subsystems work. It simply uses the facade. You can basically think of it as a wrapper class. It gives your clients this beautifully unified, simple interface, completely decoupling them from the nasty, complex subsystem classes underneath. If you want to sum it up in 4 words, one door, many rooms.
When you look at the UML architecture for this, it makes perfect sense. The client sits at the top and interacts strictly with the facade class in the middle. The client knows absolutely nothing else, just the facade. Meanwhile, it's the facade that actually delegates the work down to subsystem A, B, and C. Those subsystems are down there doing all the heavy lifting and data processing, but the client never touches them directly. Every single request routes cleanly through that one facade layer.
Number 4. Tech examples in action.
Let's look at how big tech uses this. Take Netflix, for example. When you log in and decide to watch Stranger Things, all you do is click one button, play. One single click. That's the entire user experience. But behind the scenes, that simple interface is acting as a facade for a wildly complex workflow. That click triggers an authentication service, a subscription check, it pings the recommendation engine, it spins up a CDN selection tool to find the fastest server near you, it starts a video decoder, pulls subtitles, and logs data analytics. It's a massive orchestration, but it's entirely hidden. You just grab your popcorn and enjoy the show.
The real impact of this hits home when you compare a system before and after using a facade. Think about a banking app without one. It's a tangled web. The customer code has to communicate individually with the savings account, the checking account, the investment account. The result? Insanely high coupling, ton of code duplication, and a system that is a total nightmare to maintain because any change in an account breaks the customer code. But when you introduce the facade, everything changes. The customer has exactly one line of communication, the bank service. It completely hides the specific account logic. You end up with a simpler, cleaner design with a single point of access.
Number 5. Peek at the code. So what does this actually look like in Java? In a standard banking architecture, you'd have an account interface implemented by various specific classes, your savings, your checking, your investments.
But the real magic happens in a dedicated bank service class. This class is our Facade. It exposes simple methods to the outside world, like opening an account or performing a transaction. The customer code relies entirely on this bank service and never directly instantiates or interacts with the individual account classes hidden behind it.
Let's look at what's happening inside that bank service class. Take a money transfer, for example. When a customer wants to move funds, they just call a transfer money method on the Facade. They don't have to manually code the withdrawal from account A and the deposit into account B. The bank service takes on the burden of coordinating those debit and credit operations between the right internal subsystems. It validates, it withdraws, it deposits, all safely tucked away behind that simplified interface.
And honestly, this is the big payoff right here. The resulting client code is just so incredibly elegant. You instantiate one single object, your bank service. Then you perform your operations strictly through it. You transfer, you deposit, done. One object, one interface, zero worries about the underlying database logic or complex subsystem rules. It makes the client code phenomenally easy to read, creates that crucial loose coupling we always want, and makes the whole system drastically easier to maintain long-term.
Number 6. Pros, cons, and comparisons.
Now, as great as this sounds, no pattern is perfect. The advantages are awesome. Less cuckling, a gentle learning curve for new devs on the team, and super readable client code. But you gotta watch out for the pitfalls. The absolute biggest danger here is creating a God class. That's when your Facade takes on way too many responsibilities and just grows into this unmanageable, bloated monolith itself. Also, if you're building a really tiny app, a Facade might just add unnecessary abstraction. Plus, sometimes it can actually block power users from accessing advanced subsystem features they might genuinely need. So the rule of thumb? Keep your Facade strictly focused and minimal.
You might also be wondering, how does this compare to a pattern like the factory method? Because both simplify code, right? Well, they actually solve entirely different problems. Like we touched on earlier, factory is a creational pattern. It decides which object to create and hands it back to you. The Facade is a structural pattern. It doesn't create the objects, it executes a workflow by coordinating a bunch of already existing objects. Basically, it's creation versus simplification. And keep in mind, this pattern scales way beyond simple banking or web apps. In modern tech research, the Facade pattern is crucial for advanced multi-agent systems. Think about complex AI architectures where you have a data collector agent, a preprocessor, an analyzer, a predictor. The communication protocols between them are incredibly complex. A Facade acts as the central control tower. It hides all that crazy agent-to-agent chatter and gives the client a unified, clean interface to just get the results they need without having to micromanage a whole swarm of AI agents.
Well, that wraps up this explainer, but I want to leave you with a quick challenge. Open up your current projects today and take a hard look at your architecture. Ask yourself, are you building a clean front door that makes your system a breeze to use? Or are you accidentally forcing your clients, and honestly, your future self, to navigate a tangled, frustrating web of direct dependencies? Embrace the Facade, simplify your architecture, and build better software. Thanks for hanging out with me for this explainer, and I'll catch you in the next one.